Hello, everybody, and welcome to this month's Department of Energy Python Exchange. My name is Cameron Riddell, and I will be your host this evening or afternoon or morning, of course, depending on the time zone that you're calling in from. As you all may know, our goal is to have Python thrive within the National Lab System and associated research sites. And in support of that goal, we are joined by our guest panelist, Hugo Shi, who is a data science leader with 15 years of experience with data science and software projects at companies ranging from JP Morgan to the Chicago Trading Company. He is the CTO and co-founder of Saturn Cloud, where he helps to make sure that Saturn Cloud is secure, scalable, and easy to use for all data science teams. But before we get into the agenda and introduce all of our panelists today, I want to remind everyone of a few key points about these exchanges. This call will be recorded, edited, and posted online. And as a consequence, I want you all to be conscious of the information and the questions that you may ask to ensure that you are not accidentally sharing anything that is privileged or requires clearance. Additionally, as you all know, we are a growing community, and we would love to stay in touch with each of you. If you'd like to be kept up to date with our monthly exchanges, please sign up for our mailing list, which you can find on our website, that is meetup.doepy.org. Again, that's meetup.doepy.org. You can additionally find recordings of all past exchanges on this site, as well as a recording of today's exchange once it has been edited and posted online. Now, for those of you in the audience who have never joined us for an exchange before, I'd like to share that we break these events down into 4 parts. First, we will introduce our fantastic lineup of our hosts and guest panelists so that you may get to know each of them as well as their respective fields and backgrounds and areas of expertise. Second, we'll kick off into a fun coding activity where we're going to ask our panelists some very applied questions to elicit some practical discussion about best practices in software development and where they fit into the world of an academic or scientific researcher. Third, we'll turn things over to our guest panelists who will share their prepared remarks on Saturn Cloud. And fourth, we'll wrap up with a full discussion about the points brought by our guest panelists. For everyone joining us in the audience, this will be your chance to ask questions and engage with our panel to help us all understand where Python and best practices of Python fit into your life. Now, if you do have questions, please feel free to use the Q&A widget to submit your questions. However, if you want to discuss with our panelists, please use the chat widget. Now, with that being said, I would love to have the opportunity to introduce our panelists for today. Now, I'll go ahead and share my screen. So behind me, you'll see my screen, and I'll hide in the corner over here. First, the way that we introduce our panelists is by playing a brief game. And this game is called Ask Me About. And so what I'm going to do is I'm going to go down our lineup of panelists, and I'm going to ask them to tell me what they want to hear from our audience and what they feel that they are experts in. And so let's go ahead and take a look at our host panelists. Well, that is my name up there. And so hello, everyone. My name is Cameron Riddell. Again, I am affiliated with Don't Use This Code, and I absolutely love Python. So while I may not be affiliated with a specific lab, I do have a background in academic research as I studied cognitive sciences in graduate school. And for today's exchange, I would love to discuss any and all questions related to Python as a whole, or specific concepts and uses in Python's vast scientific computing ecosystem relating to tools such as NumPy, Pandas, Matplotlib, Seaborn, Polars, and more. Now, let's move right along to our next host panelists. Our host panelist here is Tani Chavez. And Tani, I see that you're affiliated with LBNL. Can you share with our audience what you consider yourself to be an expert in and the types of questions that you would love to help us answer today?
Yeah, my background is actually in data science and machine learning. I would love to answer questions related to how we can make use of Python in order to make machine learning-based workflows more accessible to a larger community.
Excellent. Well, Tanny, thank you so much for joining us. And I know we're going to be talking about a lot about machine learning today, so your expertise will be much appreciated with our discussions that we'll have. Let's go ahead and introduce our next host panelists. Now, up here we have Kari Berry. And Kari, I see that you are affiliated with BNL. Can you share with us what it is that you consider yourself an expert in and the types of questions that you'd like to help us answer today?
Sure. So personally, I consider my skills very developed when it comes to Kubernetes and containerized compute, because prior to this, I ran a startup that was built on that technology. And I'm very focused on deploying and using that technology at BNL, and just seeing how it works within the national lab system, like getting to see NERSC has like spin, all these different ways that we run compute in our data centers. And so I'm interested to see how this conversation hooks into that from the Pythonic perspective of how am I optimizing my compute for this? Because really coming from the private sector, a lot of it was cost optimized, very focused on only using the compute time that you need. And I'm interested to see how that plays into the scientific perspective.
Excellent. Well, Kari, it is amazing to have you join us today and amazing to have your expertise here with us, because I know we're going to likely talk a lot about deployment and scalability problems as well. So thank you so much for joining. Next up, we are also joined by Tom Caswell. Tom, I see you are also affiliated with BNL. Can you share with us what it is you consider yourself an expert in and the types of questions you'd love to help us answer?
So I've been at the lab for about 10 years. One of the main things I've done is help build the Blue Sky control system. I'm also with a different hat. I'm the project lead for Matplotlib. And so I'm interested in answering questions about how you scale projects up and how you support large collaborative open source projects.
Excellent. Well, it is a pleasure to have someone with your breadth of experience and expertise on our panel. So Tom, I know you will have a lot to say with our guest panelists today. And so with that in mind, let's go ahead and introduce our guest panelists. Today, we are joined by Hugo Shi. Now, I mentioned earlier that Hugo is the CTO and co-founder of Saturn Cloud. And so Hugo, I'd love to ask you the same question. What is it that you consider yourself an expert in, and what types of questions do you want to hear from our audience today?
Yeah, okay, I don't know if I would say expert, but I love answering questions about helping data scientists be more productive. That's what I love.
Excellent. So I'm sure you'll have plenty of tips and tricks for our audience about how they can increase their productivity, whether that is easing the deployment of applications or making their compute more efficient. So thank you so much for taking the time to join us, Hugo. It is an absolute pleasure to have you. Now, with that all in mind, I would love to invite all of our host panelists up on camera, and we'll begin our first coding activity. And this coding activity is called, Is It Really That Bad? And so let's find out how to play. In this game, Is It Really That Bad? We are going to spot something in some code that we're reviewing, and we're getting excuses and excuses about it. And maybe we'll read social media posts or blog posts and say, oh, you should never do that. But we never really know why we shouldn't do that. And so each round will be presented with a code snippet. Our panelists will identify whether the choices made in that code snippet are actually all that bad. We're going to describe the circumstances when this code might cause real trouble, or the circumstances where that code snippet is completely innocuous. Our panelists will be scored, not actually, on the specificness with bonus points for relatable anecdotes and experiences working with scientific researchers and data scientists alike. So let's go ahead and jump into our very first round. Round one, how do we import? And so you're reviewing some code and all of a sudden at the top of the script, you see from module import star. How bad is it really? So I'd love to open this up for our panelists to Whoever wants to kick us off on this discussion.
I would say it depends on the specific library being used, actually, because some libraries are not actually that deep and don't have a ton of imports, but other ones might have a million classes and namespaces inside of them that vary in size. And I think the worst of this that I've seen, because I come from a Node.js JavaScript development background, were things that were designed to do very simple transformations. These very overused libraries, like there had been some vulnerabilities in recently, but they might be only used to do one sort of transformation, but people are taking in the whole package that can do everything. And it's adding to milliseconds of load time, which seems like nothing, but in a productionized service actually adds up to a lot.
Yeah, that's a very fair point there, right? Especially with the startup time, right? Some of these Python libraries are very large, and this is not going to say that if you just import some functions versus all the functions, really behind the scenes, unless lazy loading is actually implemented for that package, you will bring in the whole library. And if you're loading in pandas and you need an application to start up quick, pandas and NumPy, fairly large. And so I'd love to hear from some of our other panelists as well. Is this really all that bad?
I think this is very bad because, so here's my reason, because if you do this twice, then it becomes very hard to reason about what's actually in your namespace because you don't know all the names that are defined in two modules.
Yeah. Hugo, I completely agree with you. And even worse than not knowing what's in your namespace is when you get those conflicts or those clashes. If you did from math import star and from logging import star, well, they both have functions called log, but one is for logging an actual message, right? And the other is for taking the log transform of a value. And so two completely different functions, and depending on the order of your imports, you could really, really do some damage. So excellent point there. And Tom, I see you're off mute as well.
I agree. There's the fun bug that way back in the day, people would do from pylab import star, which would bring in sum from NumPy, which behaves similar but not identical to Python's built-in sum. And you could get yourselves into all sorts of fun trouble when, like, you accidentally pass a generator to sum and it would break in a way that I used to know very intimately and have now fortunately forgotten.
Well, hopefully we can thank, right, some core developers of other projects and matplotlib for helping you forget that error. And right, because the NumPy sum ends up ultimately gives us a NumPy scalar back out, right? And so that
it was worse. They didn't handle the input correctly.
Yeah.
Like it wouldn't iterate it.
Awful.
But
so from module import star, horrible to do, I think is the consensus. Maybe if it's a one-off script and you're just importing a very small namespace, maybe nobody's going to shout at you. But I would say for larger things, probably a pattern you want to stay away from.
I would defend it in exactly one use case, which is you're sitting in a prompt and like that code's never going to be saved. I did from blah blah import star and you just want to type it. That's as a convenience for interactive work. It's a good tool, but never in a script.
Yeah. So kind of the original goal of the pylab interface, right, was to just bring everything to the top level, make it convenient to interact with, especially for that type of quick, make an input, observe some output route that we all know and love. Awesome. Well, I think that concludes our first round. I will pause for any final remarks on this topic. If not, we'll go into round two. All right, let's jump into our second round. How do we loop? In this case, right, we have some function that loads some NumPy data. And we know that it's probably a two-dimensional data set just by the variable names in our iteration. We're assuming we're iterating over rows and then values. Is this really that bad?
So this is a big performance hit if it's a big array, in particular if you're doing math stuff. I think however, if this is in the context of a function that's going to be jitted by numba or Python, this is actually what you want, and you want to let numba have access to that to make it go faster, then you have to do something like this. And particularly there's some algorithms that can't be easily vectorized. And a corner case where you have to do this is if you have like object arrays. So you have technically a NumPy array, but you've put Python objects in it, which is nice if you want slicing, but there's no sensible ufuncs on object.
Absolutely. And so, Tom, right, one interface where you have those arbitrary objects in a NumPy and D array is, of course, our loved subplots interface for matplotlib, returning the conveniently sliceable axes. But I think apart from that, no real reason for them to be in a NumPy and D array, just convenience. And you need NumPy anyways. Any other thoughts? Is this really all that bad? So Tom mentioned, right, a performance hit if it's a large array. Is there anything else we want to add here?
Right. I think that I agree with Tom. I think also this may depend a lot in the use case. Depending, for example, if we're just going to be consecutive math operations that may very well just be suitable for just doing, for example, matrix operations. In that case, for example, we might just as well make use of those instead of having to loop around and create basically redefine or reinvent the wheel for things that already exist. So that just to put like kind of like a use case where this might not be suitable, like if we're just going to do some few set of matrix operations, perhaps in that case, this might not be needed.
Absolutely there, right? Especially one thing, Tanny, I thought you brought up that's great. If you're just doing simple mathematical operations, right, say adding a scalar, right, to every cell in this two-dimensional NumPy and D array, you're not only losing performance, as Tom suggested, but you're also losing the readability of your code and almost half of the point of using NumPy in the first place. Now, I'll pause for any final thoughts from our panelists or from our audience. If you want to share some thoughts in the chat, I would love to hear them. If not, we'll proceed into our next round. All right, let's go ahead and start round 3. In this round, this is no longer about Python code specifically, but it's how do you call Python from your terminal or from your command prompt. And now here, if you use Python 2, well, you might be familiar with having to differentiate between a system install of Python 2 or Python 3, and you would commonly call it Python 2 from the command line or Python 3. And I'm curious, is it really that bad?
I think it's one extra thing that could get lost in the documentation for how to run that code. And I also think that if you are going to store something in a script file like that, you really should throw in a shebang to make it easy to execute just from the terminal, from anywhere, that it will pick up that it is a Python script and you can just sort of run it the same way you'd run everything else. But yeah, it does sort of get into the territory of how is my local Python distribution installed, and am I in a Conda environment? Am I in a VNV? You have to ask yourself all these questions before you do this now. And as a person who's worked with a lot of Python 2.7 code, and on like Logitech Media Server and projects like that, it gets really confusing really quickly. So the easier you can make it for yourself by adding shebangs to script files that you have to run, the better.
I agree with you there, Kari. Any other thoughts from our panelists on this line of code?
I think we should consider using system managed Python more often, particularly in the context of containers and VMs. If you're going to be sitting in a container running a Linux distribution that has a full package manager, you should use that package manager. We should more often consider using that package manager to pull in Python and all the compiled extensions, because that way you're sure they're compiled in a coherent way that makes sense, rather than either like layering Conda into a container or running into all the risks of the precompiled wheels going sideways for all the reasons wheels go sideways. And in that case, if you happen to be Python 2, then this is the right path.
Absolutely. I agree with the container idea there. Use the system and Python within the container. I've also seen though on the other end of the spectrum, right? New users, if this is kind of your copy and paste example of how to run this, they'll type in Python 2 at their terminal and they'll see, oh, I'm missing this package. And then the next thing you know, they're trying to pip install to, their system's Python 2, which for some operating systems actually does very important tasks. But Hugo, I saw you came off mute. Did you have something you wanted to add?
Well, I had a question for Thomas, but I don't know if I'm derailing us too far. That's okay. We don't have to talk about this now. So the question is, how do you if you do use the system in Python, how do you handle situations where you need specific versions that are not there? So I'll preface this by saying that all of our images, we use common environments. But the reason we do that is because our users are also then going to use common to install things into it. So we have to have it anyways, which is a slightly different use case than I think what a lot of people are talking about. But yeah, that's the question. If I'm very specific about which versions of PyTorch and NumPy or whatever, and because the system Python usually doesn't have that kind of flexibility, or at least in the past experience that I've had, the system Python's never had that level of flexibility.
Uh, so I guess then either use ecosystems that do stay up to date, like don't use Debian Ancient as your base. Or if you're really relying on this as your production system to build the packages you need, or the handful of things you need additionally.
Okay.
It's just the relying on wheels and containers is the thing that worries me. Just because the vendor everything nature of wheels, you can very easily drive yourself to really weird places. I bring up an issue we had recently in Matplotlib where, the C++ underlying C++ core library changed, and if you imported the right set of packages in the right order, we'd segfault you on Windows. And because both packages had included that library of different versions, whichever one came in first depended if the backwards and forwards compatibility worked. And there's a whole zoo of those things with wheels. So,
And Tom, that was the 391 or 390 issue?
Correct.
Excellent. Well, you heard it here first. Be careful with wheels. Use this pattern if you're working in a container, working in a Docker file or something of that nature, or an image, I should say. But if you're working with simply virtual environments, maybe an explicit call to system Python is not what you're looking for. Let's go ahead and jump into our next round. How do we serialize data? Now, in this case, we are using the pickle module from Python, and we're opening up a file and dumping some data object, arbitrary Python object, into the file. Is there anything wrong with this? How bad is it really?
I love pickle like a guilty pleasure. That's all I'll say.
It's fair. It is pretty fast, I will admit. It's much faster than round tripping through a text-based file like JSON or anything like that. But Tom, I saw you came off mute.
I think it depends on who you expect to read this later. If you're writing this for your own purposes, for writing checkpoints so that you can resume, or for communicating between, workers of a multi-worker process, then this is fine. If you're going to then email this to your friend, please don't.
And Tom, I'm curious, can you emphasize a little more on why not to share pickle files, or maybe more importantly, why not to try to open pickle files that you have downloaded from the internet?
Because pickle files included enough information to recreate the Python object they were dumped from, which means they can basically run arbitrary code on the way back up. So if you do not trust who wrote it, they can basically do anything on your computer that you can do through carefully crafted objects. And there's also, pickles are not, have some cross-version compatibility issues.
Yes, I believe they cannot go backwards, right? They can go forwards. You can specify in newer versions of Python, you can specify older versions of the pickling protocol. But if you pickle something on a recent version of Python using one of the newer pickle protocols, if you try to load that pickle object from Python 2 or an early version of Python 3 that doesn't support the later pickle protocols, you are out of luck, unfortunately. So excellent points there. And Tom, I love the point that you made. If you have some data or have some object that you want to maybe move between processes, that's done for you. Or if you just want to move it from your left hand to your right hand, and it's all self-contained, you know that you are not being malicious to yourself, go ahead and use pickle. And so Hugo, a guilty pleasure, I think, is a great way to describe our pickle files.
Well, now also I think this is going to be the next prank I play on Python friends. Just send them a pickle that does something unexpected or slightly annoying on their local machine.
Absolutely. You can probably come up with a lot of very fun ideas, I'm sure. All right. On that note, let's jump into our next round here. How do we install dependencies? Now, similar-ish topic as we've seen before, but slightly different. Here we have a line of code that reads sudo pip install. And how bad is that really?
Never. Just never do this. Please never do this.
So Tom, are you telling me never do this because if something doesn't work on my computer, I shouldn't just say, you know what, I'll try it with sudo? Or is there maybe something more specific in there?
That's also true. This goes back to, as you start mixing package managers keep track of what versions are installed and make sure the dependencies of those are also installed. If you start crossing them, you will, if you change what files are on disk underneath, say, your system package manager, it can no longer correctly do its job because pip has changed things. And if you do pip on top of system packages, sometimes pip on top of conda, you can drive yourself to a system to a state that is completely unrecoverable. If you do it to a conda environment, you just delete it and try again. If you do it to your root partition, deleting and trying again is a bit harder.
Danny?
Yeah, I want to also to add to that, that nowadays, especially in science, I mean, reproducibility is a big a statement and a big thing moving forward when we publish or do anything. And I think having full control of our environments, making sure that our list of installation requirements and everything, it's transparent, and that we are very confident that whenever we start fresh in a different equipment or a different place, we're able to reproduce all our results. I think that's very important. So something like this, for example, could prevent us, or probably will very likely prevent us from being able to reproduce everything and for other people to be able to reproduce our results. So we'll probably also place it from that point of view, that in order to maintain reproducibility, we need to keep our environments pretty much clean and organized and documented.
Yeah, I think that documented there is a very important point for the reproducibility. Any other thoughts on sudo pip install? All right, then let's go ahead and we'll jump into round number 6. How do we upgrade our dependencies? So here I have a line of code. We run this from our terminal command line, pip freeze, and shove all of that output into a requirements.txt, shortened to rex.txt to fit easily on the slide here. But is there anything wrong with this? Why not just pip freeze your virtual environment or wherever and put it all into a requirements.txt?
I think like
do you mean,
oh, sorry.
We'll go Hugo and then Kari.
I was going to ask a clarifying question. Are you saying you use pip freeze to write the requirements.txt file that you would normally write by hand? That's what this example is about?
Yes.
Oh, okay. You just end up with a requirements.txt file that's overly specific and it's almost impossible to update.
Yeah. Right. And so what makes you say overly specific? What's the downside there?
Well, you'll end up with a requirements.txt file where every line has a very specific version number. And so probably if you wanted to update one of them, you would have to end up updating this weird cascade in that file, and you would have no idea which ones you'd need to touch. In fact, probably your best bet would be to go through that, delete all the versions, and then just update the one that you want, and then let the pip solver figure it out. I don't have an answer for how bad is it. It's certainly annoying for sure.
Yeah. If you want to maintain this environment or make upgrades or changes to it, there's going to be problems there, like you specified. If we want to share this with a colleague, I actually was just on a Zoom call with someone and they said, oh, I put the requirements in the requirements.txt file and I opened it and it's about 80 lines of packages. And unfortunately, probably 60 some of which I had never really heard of because they're not the packages that we use and interact with every day as users. They're dependencies of libraries that other libraries end up using. And so as a user, I'm wondering, well, what are we installing here? What are the things that I'm actually going to end up importing into my scripts? And I think that type of documentation is very important because if you want to use your requirements as a form of documentation saying these are the packages I use, well, having something that's 80 lines long is going to be very unreadable there. So I think that's an excellent point there, Hugo. Now, Kari, did you have something additional to add there?
Yeah, I feel like this is some of the advantages of using PyProject Totemal to organize your project, and that it just makes more sense. It's more human legible in terms of what packages you are importing and why you're importing them and when you should be importing them. So that's one thing, is that if you're building a project still around requirements.txt, you might want to consider some of the alternatives that are a bit more elegant and easier to understand. But also the problem that I think Hugo was touching on a little bit is that this will lock you into a specific version when a lot of software can work with a range of versions for dependencies. And if you really specify that one version, it might have a hard incompatibility with something imported by another tool that you're using. And there could be a collision there in the APIs of that utility. So, if you are flexible, if your program can work with anything before or after, you use the greater than or less than sign to specify versions, you're really making your software a lot more accessible and reducing the chances of problems springing up later.
Tom?
So I think there's two contexts in which we want to specify requirements. One of which is we're a library that you expect someone to then write code against. And you have to tell them what things you also rely on transitively. And that's where you definitely want to use the range. But there's also a mode where this is an application that you want to push out. And if you're going to solve this, if you're going to, if this is a tool that you're going to drop out, it's going to run an environment by itself, and it's going to start a process that does something. You may want to lock that down a lot more tightly so that when someone releases a new version of one of your dependencies, you don't first discover this when the production environment picks up the new one. And now suddenly it's broken at 2 a.m. because that's when the open source developer thought pushing to PyPI was a good time.
2 a.m. on a Friday as well, right? And so I think that's a very good point. I like being bold, and I'll say, set my pandas versions to 2.*, but you never know when that's going to come back to bite you. But Hugo, any additional thoughts here?
Yeah, I just want to clarify what I meant. So I'm not saying that you shouldn't freeze things. I think freezing things is very useful because for the exact reason why Thomas mentioned, like you want to make sure that when you go to release something, like your Docker image, well, I guess that's a bad example, but your application knows, exactly what your application is running with. It's more that if you're going to freeze it, that should not be the same thing as, it's almost like requirements.txt is a source file that is meant to be edited by a human. And the output is an artifact. And that's, yeah, you can kind of edit it, but it can be quite hard. And so just keep them separate. Like something that's generated by the program, like keep that there. But the thing that you intend to edit by hand, keep that separate.
I think these are all very fair points about when it's fine to use this type of pattern here or when it's not. I will say one huge thing that our requirements.txt is always missing is the version of Python that's required in the first place. And that's our environment YAMLs and things like that used by other tools allow us to also encompass. And so if you do want something to run the exact same way every time, pip freezing into requirements.txt is an okay first try, but I really hope that you recorded the version of Python you use somewhere. And if not, well, maybe use a different tool, one that's more designed for reproducibility there. But excellent, excellent discussion. Let's go ahead and talk through our final round. Now, in this final round, I want to talk about how do we visualize. And you'll see in this first line here, we import matplotlib.pyplot as plt, and we call plt.plot. Is it really that bad?
So I think in a terminal or a notebook, this is perfectly fine. Because what that's doing for you is there's a whole bunch of hidden global state, including like what figure, and then all the GUI management around that figure, and all of that that just takes care of. So if your goal is to get a view of what your data is as quickly as possible, like please do this, like that's the right thing to do. If you're then, however, if you're going to do this deep inside of a library where you're going to have users pass you in things, that's where I think it's worth being more explicit and using the explicit or object-oriented API, where you manage the axes and the figures and call plot on them, because that way the ambiguity of what is my current axis can really come to bite you. Where if you have two things that the thing that has bit me the most is in grad school, I would have two windows that I was working in, visualizing different aspects of the data, and I'd click on this one and then want to plot something on that one and type plt.plot, and it would show up on the wrong one. And then I'd have to go and I hadn't learned the remove method yet, so I'd have to go and fully remake this one. Which is just frustrating. And it's worse when your tools that you don't necessarily control do that sort of thing to you.
Yeah. Tom, I had an issue where I had a bunch of notebooks that other users had created, and they wanted me to make them more reproducible. And so I automated the execution of them, writing using IPython mb execute or one of those types of commands. And I found errors related to matplotlib because in the notebook, right, you render and close the figure after every cell when you create it. However, during the execution, Python did not know when I was done with one figure and moving on to the next one because it didn't delineate that cells, at least during the automated execution. So there are going to be odd times where this comes back to bite you, but I absolutely and wholeheartedly agree. If all you want to do is just plot some data very quickly in an interactive way, go ahead and reach for the conveniences that the tools offer you. Any final thoughts on this topic from our panelists? All right, then. That wraps up our coding activity of, is it really that bad? I want to thank you all for participating in this activity. It was a lot of fun. And now I want to move to the next phase of our Python Exchange. And so I'd like to invite Hugo up front and center to share with us your prepared remarks. So Hugo, I'll turn the stage over to you.
Okay. So I'm going to talk about building a data science machine learning platform with Kubernetes. The goal for this talk is first to understand why people need data science machine learning platforms anyways, and then get some intuition for how you would go about building a DSML platform with Kubernetes. The reason why I say get some intuition is because these platforms, they tend not to be one size fits all. It's going to depend on the scope of your organization. So I can't just say, here is the blueprint for how you should build your platform. There is no one platform probably for your organization, for everyone. However, I can give you a little bit of intuition for how Kubernetes works, some interesting Helm charts that you might want to look at, and that will hopefully give you a leg up when you do go down the journey, or if you do go down the journey of building your own platform. The goal is to cover very lightly the fundamentals of Kubernetes and help you understand how data science and machine learning concepts can be applied to Kubernetes, and give an overview of the data science machine learning ecosystem around Kubernetes. And I will say that if you already know Kubernetes, I'm going to apologize. This will be a very boring talk for you. It is going to be very high level, and it's going to be directed at people who don't know K8s very well. Okay, to set the stage and to motivate, I ask you to travel back in time with me to a bygone era. And by that, I mean 2009. So what was data science and machine learning like in 2009? So I was working as a desk quant doing data science for an options trading desk. I was responsible for tasks like cleaning data, training models, and creating analysis. I did all this on a Windows desktop computer that was issued to me when I started working for the company. And we would do analysis and then save the results in Excel spreadsheets, send them over email, send them to shared drives, things like this. This was before Jupyter Notebooks, so we weren't sending those around. And we needed to automate a lot of this. And so we would use Windows scheduled tasks running Python, and I had 4 desktop computers sitting under my desk to do this. So what's wrong with this approach? Number one, the hardware is fixed. There is no way to adapt as data volumes grow, and there are no GPUs under my desk, so I couldn't do any deep learning. Number two, the setup is very unreproducible. If someone wanted to rerun my analysis, they would have to replicate what I did on each Windows machine to set it up to run my workloads. And I am absolutely certain that I did not document the procedure for setting up each of these. Finally, this approach is very unreliable. If one of my 4 machines had a hardware failure, there'd be a long manual process to recover. Someone from the help desk would have to bring me a new desktop computer, and then I would have to start one by one installing all the dependencies that I had used on that machine, and then start it up. And of course, I'd probably make mistakes in the process that would cause delays, etc. Whenever I went on vacation, I had to be available on the phone in case something broke. So that's how things were back then, and it was pretty terrible. Let's talk about how things are now. There's still lots of teams that work primarily on local machines. There's also teams that work on cloud instances. So this is a world where maybe as a company, I hand out AWS keys to my users. They can go spin up whatever EC2 instances they want. And that definitely solves some of the scalability issues, right? Because if you're able to dispatch to EC2 instances, then you can scale up, you can use GPUs, et cetera. But it doesn't solve any of the other issues like reproducibility and reliability. If you don't explicitly document everything that goes, if the data scientists on your team don't document everything that goes into setting up each of those instances, that work won't be reproducible. And finally, there are teams that have adopted or built their own data science machine learning platforms. And that's sort of the world that I want to take us into today. So let's define first what a DSML platform is. I define it as a tool or a collection of tools that provide a certain set of capabilities. One, the ability to do exploratory analysis and create ML models, the ability to deploy models as APIs for other teams to consume, the ability to schedule jobs and data pipelines which keep the business running, the ability to deploy dashboards for executives and stakeholders to view at any time, and finally, the ability to allow members of the team to collaborate easily on. This slide here is a diagram of Jupyter Hub, and I just want to go through this real quick because it'll provide a lot of intuition for the rest of the talk. So this is the user on the left, and in Jupyter Hub, the user, all the network traffic from the user goes to a proxy. So this is a network proxy that takes the user's traffic and decides where it goes. And this is running as a Kubernetes pod as part of a deployment. Then there's another server, which is a Kubernetes pod running, which is the Jupyter Hub instance. And so if you're executing commands like I want to spin up a notebook, your request will go through the proxy and then to the hub. And then the hub will be responsible for creating a container, or I'm going to butcher some terminology for the sake of expediency. It'll create a pod which runs your Jupyter Notebook server. And then when you actually go to access it, the proxy will sort of route your traffic to the appropriate server. I'm looking at the chat real quick for questions. Oh, this is going to be too long for me to read, so I'll deal with these questions at the end. This slide here describes what I would say is the overarching diagram that subsumes all the DSML platforms we've seen in my time at Saturn Cloud from different people's Kubernetes clusters. And so this is very general. Your specific implementation will probably include parts of this, but maybe not all. And so from a high level, I would say platforms tend to be divided into 2 sections. The first section on the right is Helm charts. So Helm charts are, you can think of that as pre-packaged Kubernetes applications. And common Helm charts are Helm charts for Jupyter Hub, Helm charts for MLflow, Helm charts for a Spark cluster. So these are ways for people to install applications into a Kubernetes cluster. And many people's data science platforms might just look like a collection of different Helm charts. For example, You could install Jupyter Hub and MLflow and Spark and call it a day, or just install Jupyter Hub and call it a day. On the other side, on the left side, there are aspects of people who build their own platform. And this usually takes several flavors, the most simple of which is you give your data scientist a client library, and that client library knows how the data scientists use the client library to create the Kubernetes objects that they want to use. For example, the data scientist might use a client library to spin up a Jupyter Notebook server, or the data scientist might use a client library to deploy a Streamlit dashboard. And this is all done by creating Kubernetes objects in the cluster. And an extension of this is, instead of having a client library, to have a server do the same functionality. And so that's a useful strategy because, and I've seen many organizations do this, because once you do that, instead of having to update like 100 different client libraries, you just have to update one server. And one last thing that I'll say about this approach is that a common way that people think about this is to create different Kubernetes namespaces for every user. And I know I haven't talked about what Kubernetes namespaces are, but that's just a good way to keep everyone's Kubernetes objects separate. Now, let's talk real quick about what Kubernetes is. So Kubernetes is an open source platform designed to automate deploying, scaling, and operating containerized applications. So that encompasses many different tasks. One, container orchestration, so making sure that containers can start up and shut down gracefully. Auto scaling, so in a cloud environment, if I want to schedule a container, but I don't have enough hardware resources to do so, to automatically bring up the relevant machine in order to run the container. Self-healing, that means that if a container fails or crashes, it can be restarted by Kubernetes. And finally, Kubernetes tends to involve lots of YAML, because every Kubernetes object has an associated YAML representation. So if you're working with Kubernetes, you're going to be reading, writing, and editing lots of YAML. Now I'm going to go through just a couple Kubernetes objects, not all of them because there are too many, but this will hopefully give you the intuition for how you might go about this if and when you decide to build a platform. So the smallest unit in Kubernetes is a pod, and a pod consists of one or more running containers. Those containers can interact with each other using the file system. They can access shared storage on the file system. They can also access each other through networking. So if you're in a container in a pod and you communicate over localhost, you can then use that to interact with other containers that are running. Finally, I'll point out that pods are ephemeral, meaning when your pod completes, it goes away. Yeah, more on that later. Next up, we have deployments. So deployments are sort of one level up from pods. Deployments are typically used if I want to have n replicas of a pod. So for example, I want to run a web server. I want to have 3 containers for that web server for high availability reasons. Kubernetes will ensure that if I modify the deployment, i.e. if I change which image I want to run, it will then go ahead and make sure all the pods that it's managing are updated. Kubernetes will also ensure that if a pod crashes, it will be restarted. Jobs are similar in the sense, except jobs are for containers that will run and then complete. And you can also create cron jobs, which are objects that know how to, according to a cron schedule, create the equivalent job to get work done. A couple more objects. There's also config map and secrets. So these are objects that are used for storing key value pairs in the Kubernetes cluster. Config maps are what you would use if you wanted to store data that's not highly sensitive. But secrets are what you would use if you wanted to store data that is sensitive. And secret values are base64 encoded in the Kubernetes YAML and can be encrypted at rest. I will just call out real quick, whatever Kubernetes setup you're using, check to make sure that the secrets are encrypted at rest, because that's not always the case. Services is how you, I guess, pass network traffic to a pod. It provides a single network address for a collection of pods. And it can be, there's a couple different types, but I'll only talk about 2 of them. One type, the cluster IP type, is how you expose network traffic within the cluster. And if you wanted to expose traffic outside of the cluster, you can use a load balancer service. Finally, on the storage side, there are these objects called PVCs and PVs. Essentially, a PVC stands for a persistent value volume claim, and that represents a request for storage, whereas the PV, the persistent volume, is the actual storage. And so typically you create the PVC, and then you use the PVC in something like a deployment or a pod, and Kubernetes will create the PV for you behind the scenes. So let's walk through a concrete example. A user has a client library and they want to create themselves a Jupyter Notebook server. So the client library will go ahead and create the Kubernetes deployment that will then dispatch a pod. And maybe the user specifies which image they want to run, and that's the image that's running their Jupyter Notebook server. The client library should also create a PVC to provide the Jupyter Notebook with persistent storage. Because if you don't do that and the container shuts down, then there's no place to store any of the code that was authored. And so if you forgot to push the Git, all your work would be deleted essentially. The client library could also create a load balancer service, which would route traffic from the user to the Jupyter Notebook interface. And additionally, maybe the client library also creates a load balancer service to route traffic to the SSH port in case you wanted to expose SSH. So this is just, you don't have to do it this way, right? But this is one example of how we've seen people implement these kind of approaches in their organizations. Now, remember, I mentioned that there are ways, this is what I just described as, if you're building on the left side, a client library or a server that's creating Kubernetes objects for your users. The flip side is just using pre-canned Helm charts. And I think a lot of situations call for both. And I just want to go through a couple Helm charts that I see quite often so that people are aware of. We'll do this very quick. Jupyter Hub, I don't think that needs very much explanation. I think most people here are probably familiar with Jupyter Hub. There's MLflow that people use for experiment tracking, model versioning, and serving. Airflow that people use for running workflows. I want to ask this one question just for the group. Do people consider Airflow legacy? I think it's funny because there's a lot of new orchestrators out there that sort of cast Airflow in a legacy light, but I think the number of Airflow deployments probably outnumbers and dwarfs those deployments. So it's kind of a, I guess, contentious issue. And then finally, Prometheus and Grafana are things to be aware of. Prometheus is a time series database that we often use to store metrics like CPU and memory consumption of containers. And Grafana is a visualization dashboarding tool that can render data from Prometheus. So if you combine Prometheus and Grafana together, you can get nice visualizations for the hardware resource utilization in your cluster. And also, there's the EFK stack, or Elasticsearch, FluentBit, and Kibana. Elasticsearch is a search engine for text data. In this case, it would be for logs. FluentBit is a daemon set that will route logs to Elasticsearch, and Kibana is a GUI for Elasticsearch. So, with the EFK stack, you can store and access logs from your Kubernetes cluster. So I know that was real quick and that was a very brief overview, but hopefully the goal here is to give you the intuition that you need if you do decide to go down the route of building a platform on top of Kubernetes to sort of point you in the right direction for how you might begin doing it. And then I'll open up for questions. So I'll just go ahead and read this so that everyone has it. In Matt Rockman's talk at SciPy a month ago, he argued that K8s and containers are a good fit for long-running web services, but a bad fit for data science environments because data science environments need to run for a short time and have quickly evolving software requirements. Have you also noticed some friction there, and what strategies have you used to remove it? So I'm not sure what that. So the first point about data science environments needing to run for a short time, I'm not sure what that means. I think the individual workloads within the data science platform may need to run for a short time, but the platform itself generally runs for a long time. Right? If your company is investing in a platform, you're going to be running that platform for years and years and years. And then in terms of quickly evolving software requirements, I'm not, Dan, if you have clarification, maybe we can dive deeper. But for me, if you have quickly evolving software requirements, that just means that you're going to be updating your Docker images quite often. And so I think updating your Docker images when you want to try new libraries is good.
Hugo, I have kind of an extension building on that question, if I may.
Okay, yeah.
So for rapidly changing environments, for that portion of it, oftentimes we'll work with data scientists who say, oh, I really want to use the new version of, insert package X. At
Yes.
what point do you decide there's enough critical interest to actually upgrade your production environment to actually use package X?
Ah, um, I'm gonna, okay, so this is my cop-out answer. Because what we do is we let our users install things on top of Docker images. So that sort of circumvents the problem. Like for us, data scientists will usually install packages interactively just to try it out.
Yeah.
And then we have a user interface for installing packages at startup. You can think of that as putting a little script before any of their code runs that installs packages. And then we encourage them to build images after that once they're happy with it. So um, I think it is good to have a reference production environment, but I would encourage, I think it's good to let data scientists experiment with the packages that they use. I think saying, data scientists, you have to use this reference stack, I think that's pretty damaging.
I appreciate that answer. Sounds like you let your data scientists be very flexible with how they approach problems. They can try things out, try new packages or new versions out, and quickly, if they can put something together, get it running for the end users or for upper levels as well. Are there any other questions, either from our host panelists or our audience for Hugo?
Yeah, one thing came to mind during your presentation, and it's sort of that I'd worked with a similar tool called Kubeflow. And what this tool was doing was taking, basically making pipelines out of containers that would spin up to run your, whether you're doing ELT or other processes, and then training and all these things. It would turn all that into a sequence of containers that were specialized for each task. How does your product compare to that in terms of deployment, management? It seemed pretty succinct.
So we can talk about the product, but essentially our workflow orchestration or our pipeline stuff is, I would say, more simplistic. So for scheduling things, we just rely on Kubernetes projects. So because that's for us, it's because it's easy to map that mentally to like the Jupyter environment that people are working in, because they can just you're just running a command in a container that's has the same specs as what you were doing your research in. When we have users that want to use more sophisticated things, we generally refer them to tools like Prefect, Dagster. I would say those two are the ones that we generally refer people to. So I think having really sophisticated workflow orchestration, at least I think for a lot of our customers, that's not a critical need, but there are others that for which it is a critical need. And for that, we recommend it.
Fantastic. Well, if there are no other questions, that does bring us right up to the top of the hour. And so I want to say that this has been an absolutely fantastic exchange. And I want to extend a huge thank you to Hugo, as well as a huge thank you to our audience for joining us this month. Now, if you're not already signed up for our newsletter, make sure that you subscribe, and you can find your subscription link on our website. That's meetup.doepy.org. Or if you don't like receiving just one email per month, make sure you keep a regular eye on that same website for information about our upcoming exchange next month, where we'll be joined by Francisco Palm from Quant. I want to thank you all again for joining, and I hope to see you all next time. Thanks, everyone.